Hello guys, welcome to another team up session in June, July. July. And today, we have some interesting topics as usual. My good friend Jarno will begin with the first hour, or maybe a little bit longer. We will see how it goes. So say hi to Jarno, of course. He's also here.
Let me say hi to everyone there then.
Yeah.
It's
So
good being here again.
on this beautiful day or evening for us in the Netherlands. And I will do the second part with hopefully a good structured reception and overflow. So let's no longer speak and just go to the action. So I give the word to Jorno, and he will show some SQL injections, I believe. So enjoy and have fun.
Yes, thank you very much. And yes, I will show some SQL injection, but I will also show some PHP type juggling, which is, of course, a vulnerability in an older PHP version. First of all, thank you all for being here. As you can see in the screen, I am doing this box falafel this evening to show some PHP type juggling and to show some MySQL injection. This is rated as a hard machine, so well, I guess we cannot play it until we are root, but we will hope to reach the part where we can do some PHP type juggling. So yeah, usually I start with a little background, and today I will do as well. This will give you the time to boot up your machine if you want to follow along. I want to explain the type juggling and a bit of SQL injection as part of a Hack the Box machine, as we just discussed. So yeah, I did prepare this machine, and we will run through it as if we know everything and we are a god at capture the flag challenges. But remember, I played this machine before and struggled with it before. So if you want to follow along, please boot up your machine while I give a little background about PHP type juggling, and let's see where we get. PHP type juggling is an attack vector that is specific for PHP code, as the name suggests. And in the falafel machine we are going to play, we can discover a PHP type juggling vulnerability. This attack vector has something to do with PHP trying to guess the type of input we are trying to use. And this is going to be a little bit of a difficult part to explain, but I'll do my best. And if you have any questions, please let me know. But we're going to talk about types. In other programming languages, we tell the program what type to expect. Like in JavaScript or in C#, we specify a string like this, string, and then we give the string a name, whatever, and we specify the string. And because we specify the variable as a string, the language or the program knows this is a string. Well, in PHP, we just don't do this part. We do it like this without the string. And because we do it without the string, PHP tries to define the type itself. So when a string is defined, like in this example, in a variable, that variable will be defined by PHP as a string. PHP juggles its type based on the input, so keep that in mind during this talk. Besides that, we have something called a loose comparison and a thing that is called a strict comparison. So let me explain this and how this fits in this picture. A strict comparison compares both the data and the type, and the loose comparison only looks at the context to understand what type of data or what type the data is, and then it compares its values. Keep this in mind, I will explain this to make it more understandable. As you might or might not know, a strict comparison in PHP is defined by using three equal signs. So if we do 1 equals 1, then this is a strict comparison. As you can guess, a loose comparison is defined by two equal signs. As two equal signs is a comparison or a strict comparison in other languages, it makes sense that most of the time 2 instead of 3 equal signs are used when comparing values, especially by developers that are working primarily with other languages. So let's take a look at this picture here. Here we see, let me enlarge it a little bit. Here we see a table with a strict comparison. As we can see on the top, we have 3 equal signs. And here only when the type and the value are the same, the comparison will be validated to true. So when we have like an integer 1 right here, that is compared to another integer 1, it will be evaluated to true. And the same is for strings. So when I compare the string of 1 to the string of 1, it will also be compared to true. And this is with a strict comparison. Now let's take a look at the loose comparisons. As you immediately see, this picture looks a little bit different. We see the same truths. So we have all the green ones we have seen in the previous picture. Let me also enlarge this one a little bit. So, yeah, so we see all the green truths as we had before. Obviously, when I compare the integer 1 with the integer 1, it will still be evaluated as true. The funny thing is, with a loose comparison, when I have an integer of 1 and a boolean of true, and I compare both of them, it will also be evaluated as a true. This is strange because here we are comparing 2 different types of data. We are comparing integers and we are comparing a boolean, and the same we can see in the table is, for instance, a string of 1 compared to an integer of 1. That will also be evaluated to true. So as we go back here to this example, why would this be? Why would, for instance, the integer of 0 will be evaluated to true when it is compared to a string of 0? And this is because here the 0 might be interpreted as a boolean instead of an integer, or maybe like what makes it more clear, like this. When I compare the integer of 0 with the boolean of false, then we see it's evaluated as a true. And when I compare the integer 1 with the boolean of true, it's always evaluated as a true. So, and this is, as I just said, because the 0 is interpreted as a boolean instead of an integer. In that case, the 0 boolean is indeed false and compares to false. So also, let's take a look at, well, we can look at arrays. Let me not make it more difficult than it is. Looking at this table, we can see that multiple types of data and values are compared or evaluated as a true when used in a loose comparison. So, to better understand this, we can take a look at what the PHP manual states. Because in the PHP manual, something is written about this. And it says when a string is evaluated in a numeric context, the resulting value and type are determined as follows. If the string does not contain any of the characters, like a dot, a lower e, or a capital E, and the numeric value fits into integer type limits as defined by the PHP int max in the configuration file, the string will be evaluated as an integer. All other cases, it will be evaluated as a float. The value is given by the initial portion of the string. If the string starts with a valid numeric data, this will be the value that is used, and otherwise the value will be 0. Valid numeric data is an optional sign followed by 1 or more digits, optionally containing a decimal point, followed by an optional exponent. And the exponent is, like we said before, a lower or a capital E, followed by 1 or more digits. Still maybe very theoretical, but let's play with this for a moment. Let's start PHP in interactive mode. And let us compare a string that contains a hexadecimal value, and let's compare this one to an integer. So when we do a variable dump, we will comparing the string 0x, and because we are using 0x, it will be seen as hexadecimal like this. We will use a loose comparison, and we will compare this with the integer 43690. Now, PHP, we have to end it with a semicolon. To us, at this moment, this evaluates to false, or it gives us an error. And this is because we are using a PHP version that is higher than version 7. Let me exit this and look at the version. We are using PHP version 7.4. And in this version, a lot of issues are resolved, also when comparing different types of data. But keep in mind, a lot of web servers are not using PHP 7 or newer, and we will see this when we are working on the Falafel machine in a bit. Yeah. When we are working on the Falafel machine, this comparison will be evaluated to a true, because here the hex string of AAAA is compared to the integer 43690. And because the value in hex is the same, PHP juggles the type of the hexadecimal string to an integer and evaluates this loose comparison to a true. And this might be an interesting behavior, right? With this knowledge, we are mostly interested in the scientific exponential number notation and other different difficult thing to explain. A scientific exponential number is a base 10 number notation usually used to note down very long numbers. Because here the PHP manual indices that anytime we see a string that starts with any number of digits followed by the lower capital E, which is then followed by any number of digits like this, and only digits. And this string is used in a numeric context, such as a comparison to another number. It will be evaluated as a number. In other words, PHP will see this as a scientific base 10 number and thus interpret it as a number. So let's test this. And since the interpretation rules for exponent notations have not changed, we can test this on our own machine. So again, let's start PHP with the S. That's funny. Let's do it like this. In interactive mode, and let's do another variable dump. Variable dump. And we will compare 0e AAA again. And let's see if this is equal to 0. Well, here, because the string is not a scientific exponential number, this is a string, and the string is compared to an integer, noted as string, but translated to an integer by PHP, the result here is false. I hope this is a little bit clear. If there are any questions, please let me know. Now, let's use a real scientific exponential number. That will look something like this, digits only. And we will compare this one to 0. It is, in fact, evaluated to true. This evaluates to true because here PHP sees the scientific exponential number and the 0 value as integers. The 0 will always be 0 because any number multiplied by 0 will always be 0. So here a 0 integer is compared to another 0 integer, and thus this evaluates to true because everything that is after the 0 is not taking into account. So basically 0 is equal to 0, and PHP thinks both are integers. This evaluates to true. Now, almost there for this explanation about loose comparisons and PHP type juggling. Let's now use a scientific exponential number and a zero integer. Because just as we've seen before, we have used two strings, and now we will change this to an integer. And this again evaluates to true, because again, PHP juggles the type of the string to an integer with the value of 0 because it is compared to another integer. And thus, this will be evaluated as true. So, it's always best to use strict comparisons, especially on values required by a user input. So knowing about this vulnerability, does anybody know when this might become in handy, when we can use this from an attacker's point of view? Let's assume a password is hashed with MD5 or SHA-1 in a database. And then let's consider that the hexadecimal character space used for the representation of the hash type is, as we know, A2F and also capital A2F, and then again 0 to 9. This is the hexadecimal representation. And this implies that it may be possible to discover a plain text value whose MD5 hash conforms to the format of a scientific exponent notation. In the case of MD5, that is indeed true, and the specific string was discovered by Michael Spacek, the MD5 hash of the string, and it's this string 2406107008. When this is hashed, we get, and let me copy paste that like this. When we MD5 hash this string, we will get this hash starting with a 0e. And this is what we call a magic hash because it translates to a valid number formatted in the scientific exponential notation, and its value evaluates to 0. So again, let's test this when we do a variable dump. And we will dump this or compare this in a loose comparison to the 0, like this. We get a parse error. Why do we get a parse error? Oh, right. We are using PHP 7. We have to do this in an older version of PHP, obviously, but this will be evaluated to true. Now, can you start to see how things could go wrong in cases where an attacker-controlled value is hashed using MD5 first and then processed using loose comparisons? Then let's also say the application only uses a 10-character substring of the hash instead of the full hash. This will even give us a larger key space to operate in. So, as an example, let's assume a loose comparison is used while updating a password. We may need to provide an old password, and this password will be MD5 hashed and compared to the MD5 hashed password in the database. When the hash in the database starts with 0x, and we provide the password of 2406107008, which is MD5 hashed into the magical hash, the integer 0 will be compared to another integer 0 and thus evaluates in a true. And when this is the case, we are allowed to change the password even when the rest of the hash does not match and we don't know the real old password. So, well, we have more magic hashes, and one of the pages that has a nice sum up of these is this page, this GitHub page. This page shows us multiple magic hashes for MD5, SHA-1, and SHA-224, 256. And this is all, yes, this is all. Well, I hope the PHP type juggling part is at least a little bit clearer. Now, let's see this in action, and I hope that everyone that wants to play along has started the machine, because we will fly through this hard machine until we reach the PHP type juggling vulnerability. The machine is Falafel, and I have already started the machine. It listens at 10.10.10.73. And as always, let me exit this. And as always, I would start off with an nmap scan, and to speed things up, I already did the scan. The scan can look something like this. We can scan all the ports, enumerate with default scripts, enumerate versions, give us a verbose output, output all formats with a name like this, and then the IP we are working with. And let me now look at the results. When we take a look at the results, these are the results, and there are not many open ports. We have a port 80 that runs Apache HTTPD, and thus is probably a Ubuntu-based machine, and there is a robots.txt file disallowing the access to TXT files. I hope. Well, here it is. I was searching for it myself. I knew it was there, but here is the found robots.txt file, where there is one disallowed entry, and it disallows the indexing of all text files. Now, let's examine the page itself. So HTTP 10.10.10.73, if I'm not mistaken. Welcome to Falafel Lovers, the social network for people who just love falafel. And this is the beta version of the site. There is not much here for us to play with. We have the home page, and I think there is not much in the source code. Well, I know there is not much we can use in the source code, and there is one other link, and that's the login page. We might be able to test some default credentials here, like admin, but none of them will work. Interesting, however, and we will see this when we try multiple names, is for admin, we get wrong identification admin. And when we use another username, we get the notification of try again. So let's keep this in mind, because this might give us the chance to enumerate usernames. Now, the next logical thing to do is to run a GoBuster scan. And here, make sure to include the .txt extension, because clearly, according to the robots.txt file, there might be some TXT files they want to hide from the search engines, and we might be interested in those. A typical GoBuster scan will look something like this, where the URL we are scanning is our page. We are using a word list, in this case, directory list 2.3 medium. We want to include the .txt extension, and we do that with .x. We give it 30 threads to handle that once, and we output the scan results to a file. Obviously, I already run the GoBuster scan, and these are the results of the scan. And in this scan, we do not see a lot of interesting things, except for maybe cyberlaw.txt, which is pretty weird. So let's take a look at what this means. Cyberlaw.txt exists and gives us some information. From Falafel Network admins at admin@falafel, we have an urgent malicious site takeover. That sounds pretty serious. 2 lawyers at Falafel hack the box, and devs at Falafel hack the box. A user named Chris has informed me that he could log into my account without knowing the password, then take full control of the website using the image upload feature. We got a cyber protection on the login form, and the senior PHP developer worked on filtering the URL of the upload. So I have no idea how he did it. Dear lawyers, please handle him. I believe Cyberlaw is on our side. Dear developers, fix this broken site as soon as possible with a little typo. So what do we learn from this file? We have a few finds. We have, first of all, we have 3 new email addresses, admin@falafel. Yeah, sure. Okay, so zal ik dat even vertellen? Okay, so I just heard that within 10 minutes, my call will be disconnected because we are using the free version of Zoom. Yeah, I know. So within 10 minutes, when the call stops, we will call in again and we will continue with the box. Continuing now for another 10 minutes, we have admin, lawyers, and devs at Falafel. We have a user called Chris, and we have a hint, login without knowing the password. That's interesting. And abuse the image upload feature. Upload is seemingly sanitized. So let's check the usernames we have at the login panel. I do not have to close that. Login. Well, we have devs, right? Okay, we get the notification, try again. So I think devs is not an active username. Lawyers also results in trying again, and we have Chris. And Chris gives me wrong identification of Chris, which led me to assume that Chris is indeed an existing username. And of course, we already knew that admin did exist, which also gives us a wrong identification. So now we have some valid information. We can try to brute force the password. I did this, and sadly, this has given me 0 results. So let's not waste any time on brute forcing. And if brute forcing is not an option, we might be able to perform some SQL injection. So let me explain this a little bit. Let's imagine the SQL syntax of this form looks like the following. Let me open Sublime Text. Let's say that the SQL query looks something like this, where we select everything from the users table, where the username equals to the username we enter in the form, and the password also equals to the password we fill in this form. Then let's try, let's say we try to let the database return all the values to us using a union select. And we can do this with a payload that looks something like this. When we enter this in the username field, the SQL query will be changed to this. Because everything behind these dashes is truncated, so everything behind this is removed. And what we say here is show us everything where username is admin, and union select 1. Let's try this for a second. Maybe this works and gives us some information in return. It does not, except for the fact that we have another message, hacking attempt detected. All right. This might indice there is SQL injection protection in place, and we cannot use union select statements. So if there is a SQL injection vulnerability, we will probably not be able to display the data in a readable format from the database on the front page. That would be handy, that would be quick, but it doesn't look like this is going to work. And in that case, we must resort to a blind Boolean-based attacks. Of course, we got a few different blind SQL injection attacks, and in this case, we are going to talk about the Boolean-based ones. When we can make sure the front page replies with wrong identification, when a request is correct, end with try again when a request is false, like it already does when we enter a correct or a wrong username. So let's test this and create a SQL string that always results in the true. So that always gives us the notification of a wrong identification, because wrong identification in our tests equals to true. So let's say we change this string to a string that looks like this. Select everything from users where username is admin and nothing more than this, because this looks like a valid SQL string. Admin does exist in the database, as we already knew. So yeah, to do this, that's very simple. We will enter this in the username field, because we will use the quote to nicely close the SQL string, and we will use the dashes to cut off the rest of the hard-coded SQL string. So when we use this, let's see what happens. Okay, we have a wrong identification, admin. So we know our SQL injection must be successful by cutting off the password and resolving only the username. Did you say something, Melvin? 30 seconds remain. Well, okay, so let me just disconnect and call you again, if that's okay. Oh, nice. Let's do it like that. Now, how can I end this call if it doesn't disconnect me? Oh, it's quit. Yeah, of course I can speak. Okay, so if everything works well, my screen is shared again. Cool. So the last thing we did was doing a little bit of a SQL injection and resolving a SQL string that evaluated to true. So we have just tested that our injection works. Now we can also the next thing we are going to do is ask it a question that will also be evaluated to true, but to make the SQL string a little bit larger. So let's see if we can add our own questions to the string. So one thing that will always be evaluated to true is 1 is equal to 1, because that must be true, right? So let's pick this, and we again get the wrong identification of admin. And now the website is actually telling me that this SQL string is correct and the answer is true. Let's test this by giving me a false answer. So 1 is equal to 2, which will be evaluated to false. And yes, we get try again. So in combination with the result string on the front-end page, we can ask questions to the backend database. We can now craft our payloads to extract data from this database. And because we have to do this character by character, this is a long and tedious process. We can automate this with a Python script. This is cool to do, and we might be doing this in the second talk. So please let me know if you are interested in creating a script like this to make a SQL injection. But for now, let's use an automated tool like SQL Map to extract content pretty quickly. Let's capture a normal request in Burp Suite and save it so that we can use the request in SQL Map. So let me start off Burp. Which takes a little while. I thought it was going to ask me, please update, because I need an update, but it doesn't, so that's fine. Inception is on. That's my cookie. Burp Suite. And let's simply ask admin, like this. Let's send this to the repeater, forward the request. And now let's save the request. Copy to file. And let's call this request.txt. And now we can use this request file in SQL Map. And by using this file, SQL Map knows exactly where we are trying to reach, what website we are trying to reach, and some of the variables that are used during a post request. Let's minimize Burp again. Clear the screen. And let us specify our SQL Map question. We will use SQL Map. We will use -r for request.txt. That's our file. We want to have triple verbose logging. And in this case, we are going to use level 5 of scanning because level 5 fires more SQL strings to the database than level 1 does. So yes, it takes longer, but the chance of success is bigger. Level 5 is what will trigger at least the SQL injection and gives us some results. Also use the batch mode. Using batch will make sure that the system will not ask me the questions. It will just use the default questions and continue. And this thing is important. It has to look at the string on the website that when something is evaluated to a true and the string is wrong identification. Like this. Now, to speed up the process, I know there is a MySQL backend, so let's just specify the database management system. DBMS is MySQL. So now SQL Map only fires MySQL SQL strings instead of all the others. And finally, let's flush my session. So my stored results are not being used in SQL Map. And if I did everything correctly, and we can turn interception off. And in fact, I can also turn Burp Suite off. So let's run this SQL Map command. And let's see what we get. It tries a bunch of payloads, as you can see, because we defined the verbose logging, which is actually pretty interesting when we know that some kind of a string works. We can see how it works. And to do all this by hand is, well, pretty hard. And it shouldn't take that long. At least, that's what I thought. That's the thing with level 5, it tries so many payloads. Does take a long time to do. And giving the time, I think I will stop this. Do you want to proceed? Skip current test and detection phrase. Next change for both the quit. Because I can tell you that it will resolve a string and it will say, yes, this page is vulnerable. So let's simply, flush session is okay. Let's do the next thing, and that's ask the databases. What kind of databases are available on the system? Well, I don't think this speeds up a lot of the process because now again it tries to find its injection point. And if I would have continued the other search, the injection point was known to it. To make everything even more fast, let me not flush the session so it can use my stored information like this. I thought there was some stored information. Maybe there's none. Yeah, well, we simply have to wait this one out. Given the time, I think we will reach the PHP type juggling vulnerability, but I can tell you for sure that we will not will make it to the user part of this box and not to the root part, but maybe something for next time. Because in my opinion, the SQL injection and the PHP type juggling parts are the most interesting of this machine, although there are some other interesting things. So, well, yeah. Let me think about continuing this machine for future. And when I would create a video, I would pause the video and continue when this was done. But since it's a stream, it's it's pretty hard to do. None? Oh. Oh. So it's pretty hot. I don't know how hot it is in this room, but it's at least like, I don't know, 25 degrees or something. Yeah, it's insane. And I think Monday is is the hottest day of the week. And that evening we are participating. My youngest daughter is having a musical at school, so that will be fun with 200 parents in a room watching a musical with 25 degrees. I think it's hot. Yeah, it takes a long time. I can't remember last time I did this, it took so long, but I was probably multitasking, and well, time flies when you're doing multiple things. let me take another look at my Burp Suite request. Yes, we did have a password field and we had the admin field, so that should be okay. Have I saved my request file from the last time I've tried this machine? Nope, I did not. The thing is, you have to use level 5 for SQLmap to find the injection point, because at level 4, it simply doesn't find it. Oh, absolutely. It saved me so many times. It does not seem to be injectable, it says. That's interesting. Come on, it's pretty weird. Username is this. Well, maybe I should not have used the string to cut the command off. But my guess is it's simply testing the variable username and not something I've put in there. I'm not sure. Let's save this one as a request file again. And simply cancel this. I really feel it's taking way too long. Let's try with a new request file. Looks pretty interesting. Show this to your colleagues. It looks very cool. Yeah. I know that one. Geek Typer. I think it was Geek Typer. Matrix. Yeah, right. It is. Yeah, something like this. Passive. Yeah. Thank you very much. I wish this one was a little bit faster so we can. Right. I had to say this. Okay. So it did find an injection point, and it finds two available databases for us to use. Information schema and of course Falafel, and we are most interested in the Falafel database. Now we know that the Falafel database exists. Let's specify this with -d. We will use Falafel, and we are interested in the tables that are inside of Falafel. And that was pretty quick. It did find one table, and the table is called users. Nice. So the one thing we have to do is simply specify we want to use that table, the table called users, and dump all the data inside of this table, --dump, and let's wait a few seconds until the dump is completed. And the nice thing to show here is all of the strings that you see is actually, this is the injection it is using. So these are the strings that if I would copy paste them and use them in the username field, it would also work. Obviously, this is a lot faster. The character you are seeing here at this column 24, 25. So it's now resolving the 27th, the 28th character. So this, yeah, it goes character by character, but it goes pretty fast. And when it's at the end of the data, it will return all the data it did find. So imagine if you have to do this manually. It could be worse, true. I, I think you can tell us something about that, right? Not to. Okay, so what it did now, it found this table where we have two users, um, admin and Chris, and we have some hashes. And because we used batch at SQL map, it didn't ask us if we want SQL map to crack the passwords. It just did. So it uses the default word list and cracked one of the hashes. And the password of Chris is juggling. If we would have done this manually, we would have pasted this hash inside of a file and we would have used hashcat to crack it with something like this. Hashcat-a for the attack mode, and as attack mode we use 0, and 0 is working with word list. -m is the mode of the type of the hash we need to crack, and 0 again is an MD5 hash. Then we will specify the file that contains our hashes. After that, we will specify the word list we will use to crack the hash, and we will use --force because my virtual machine does not have a graphical card. And we are almost at the type juggling part, so let me continue to that. The password of Chris is juggling. Let's not Google the hashes because the password of the admin hash is already leaked. And where's the fun in that? So let's just now log in as Chris. Chris with juggling. Did I do that? Oh, that I did that right. Juggler by day, hacker by night. Hey, my name is Chris and I work at the local circus as a juggler. After work, I always eat falafel. By night, I pen test random websites as a hobby. It's funny how sometimes both the hobby and work have something in common. Well, if we know that the password is juggling, we have some text that says juggler by day and hacker by night, and that it has something in common. We know at this point we might Google for juggling. Well, we do not have to Google because I have just explained type juggling. Yeah, so this spoils our next step. Let's take another look at the admin hash again. This one. And the hash starts with 0e, as we have discussed before. And thus, this is a scientific exponential number notation. And this means that when a loose comparison is being used, the given password needs to be equal to the integer of 0. So it will be evaluated as 0 and the rest is not taken into account. As we already discussed, there is the magic hash that also starts with 00x. And that was the string 2406107008. And when this one was MD5 hashed, we got that magic string. So then the comparison will be again, as explained, 0 is equal to 0, which of course will be evaluated to true even when the types do not match, because PHP juggles the type based on what it sees and knows. So let me simply try to log out. That will work, and log in again with admin. And now we will use the string that is, when it is MD5 hashed, it is hashed as that magical string. So let's use 2406107008. Submit this, and we have a successful logging as an administrator. Meaning at this website, a loose comparison is being used for comparing the password and an older PHP version prior to version 7 is being used. This is where using a loose comparison and abusing PHP type juggling is a real vulnerability that we still see sometimes in the real world when comparing values, especially when a user has the ability to control both the values using a loose comparison. This is a real vulnerability. So this way the user can always evaluate this to a true. Now, we are logged in as an admin. But giving time, I think I will end my part here. Maybe we will keep this in mind and continue with this box another time, because this is a real fun box to do and it has some magic tricks up on the sleeve that are pretty nice to talk about. But for now, I think this was enough, and at least we have seen the PHP type juggling part in action. Melvin, I think I'm going to give the microphone to you. Let me see. Yeah, I can see a Kali machine. And no, we can. we're still seeing your Kali machine. I'm very sorry, we can't. All right. Yeah, we see. Uh, Melvin, I have a feeling that the images or the screen is delayed. So when we are talking. I'm not seeing it. I'm just seeing it like 5 seconds later. Um, I don't know what to do about it, but That's
Do you hear me now?
nope.
Give it a second. Do you hear me?
Yes.
Yeah, I think, yeah, okay, it's fixed. Okay, sorry guys. uh, do, do I need to start over all of this or can we continue? Did it knew that nobody was hearing something? So yeah, what do you guys want? Do we need to start over or can we continue from here? If we need to start over then I think we don't have enough time to do all it again, but okay, let's continue. And yeah, I hope you guys hear it for the first time. But we are now at the part that we are looking for bad characters. So you can clearly see that those are those are the list of bad characters that we are checking. And we have a bad character so far I can see because this is not good. We are going from 79. A, B, C, D, E, F, but I don't see 80. Oh wait, here's 80. But this is not good. This is all messed up. Don't know what's happening here, but it's not happening very well. So we have a bad character, that's for sure. A, B, C, D, E. I think 7F. 7F, but I don't see the 80. And now I hear an echo. Yeah, I think the 80 is a bad character. As I don't see it here in the list. So let me remove. Or it's possible that there's no. Okay, let me remove to 70. So let me remove this part. Because I'm not sure if we have a space problem, that we probably don't have enough space that fits here for all the bad characters. That is one option. That means that sometimes there's a problem that you have like this much space. Of course, you cannot place your shellcode in this small space. So you need to find a way to solve it, but that's not now. But it can happen that this is the space that we have and we don't see all the other characters. So let me do it this way. Let me go back to my Kali machine. I have removed the first part of our bad characters, as you can see. This was the first part, how we had it. By removing this part. And we are going to remove our boxhold. And we have our export again. So let me go back to our Windows machine and let me see if this is indeed everything that we have. Okay, let me download our file again. Okay, let me open Boxsoft. Let me run administrator, let me attach it. I'm already happy that everything goes very smoothly today. So, besides the sound problem at the beginning, but the last time we could not even start with this. So yeah, it's going better. Yes, we click on try, we click on next. I'm moving this file to it, and there's a crash. And let me check the ASP header. Okay, we see 70, but nope. I don't see 80. Nope, I think 80 is a bad character if I can see. So let me remove the 80. Just checking. Bad charge equal nukes 80. So let me remove 80 and see what is happening. And let me Python 3 exploit. Okay. Let me remove this one. Let me download it again. Let me start it. Okay, attach to progress. Audio converter. Okay, let me continue. Okay, try. Next, and we have it. Check the ASP header. The ASP pointer. And something is really messing up here. Who are those C2s? It's weird. Because you have 81, 82, 83, 84, 85, 86, 87, 88, but you always have those C2s, so and it is not happening here. So there's something wrong, that's for sure. So we have a bad character, but probably earlier. There's one other way to find bad characters, and it is a really time-consuming way to do it, but 99% this will definitely work. Wait a second. So you can split this bad characters in multiple parts. So what we're going to do is bad chars 2, edit. I'm going to, let me check, to 80, so this part, okay. Let me add this part to this part, and let me then remove this. Okay, so now we have two parts. I'm going to first send this part. If there are no bad characters in this part, then I'm going to send this part. If there is a bad character in this part, I'm going to split it again, and again, and again. And then I am limiting the available characters that can be wrong by doing it this way. And when is this useful? You probably ask your own. It is useful when you have a problem, like I said at the beginning, when you have only a limited amount of space. So, for example, you have this amount of space. You cannot fit all those bad characters in this little amount of space. So then what you can do is splitting it up and send one piece of bad character at a time. And that's one way to find it then, if there's a space limit problem. So let me, oh shit, not saving. Let me do it in this way. So I hope. Else we are just going to continue. Because I already know the bad characters. I already did it before. But yeah, I just want to show you guys how to find bad characters. So let me attach it. Let me audio converter. And let me continue. Okay. Try next. Let me. Oh wait, did I download? I didn't download it probably. Oh wait, I did. No, I didn't download it. Nope. My apologies. No, no play it. Okay, let me download it. Okay. We are starting the software. You're probably wondering that this is a really repeating task. Always starting with the debugger as admin, attaching the software and pressing G to continue. Yes, that is indeed true. And if you know a way to do this automatically, then I love to hear it. Because I always am tired after doing this 1,000 times. And you can clearly see that we have our first part. Okay, so it looks to me that there are no bad characters in this part. It seems all nice and well. It does count from 1 to, let me check, to where it is 6F. 6F, yes. I see it. 6F, 6E, and then 2, 4. So there are no bad characters in this part, you will say. So we are going back and going to send our bad characters 2. So our second part of bad characters. Okay, now I have changed the exploit. I'm going to remove it. Going to generate our new file. Going to kill this one. Going to remove our old file before I do it again. Download our file. Start our team. Run as administrator. Add test to the progress. And clicking continue. Okay, now let's try it again. Next. Move the file. And the first 55. Okay. And yes, we can again see that it is messed up. Because where are those C's coming from? What is C2? where does it come from? It's not from my bad character. So yeah, there's definitely a bad character in this part. And I was thinking about 80, but 7A, 7B, 7C, 7D, 7E, 7F. And I don't see the 80. So it must be 7F or 80. We already tried removing 80, so let me try remove 7F. That is perhaps the case. No idea if that will... Okay. I have removed 7F. Let me generate the exploit again. Okay. If this is not working, then I'm going to continue and just tell you guys what the bad characters will be, should be. But yeah, there's one downside by checking bad characters from an exploit that someone else made. You really need to check if the exploit that has been made from the guy who made it on, for example, ExploitDB, if it has been built on the same operating system that you are using. For example, I am using Windows 10, and the one who created the exploit was using Windows 7. So Windows 7 and 10, they use different addresses. So yeah, you cannot blindly believe that the same bad characters will apply. So it's always good practice to double check and be sure that it is indeed the case. And yeah, it's also not 7F, so it must be 80. I'm going to try 80 one more time. It's weird that... Okay, we have 7F, 7E, 7F. Okay. Okay. Okay, run as administrator. Did I press no? Oh, goddammit. Audio converter, yes. Continue. Okay. Now, please may the demo gods be with me and show me that this 80 is a bad character. No. No, I don't know what's happening, but it's acting really weird. I don't know where the see-through comes from. But if you check the exploit, then it says that the bad characters are the null byte. As I already mentioned at the beginning, the null byte is 99% the bad character, but the other two characters are 0A and 0D, which is weird, but because if you saw our stream, 0A and 0D were just working fine, so yeah. But let's assume that those are bad characters and let's continue building our structured exception header. So the next part that we are going to do is finding a pop-pop return. And that's one of a more difficult task. Let me check. Yeah, we need to find a pop return, and there is a script who can do that for us. If I can find the script. Yeah, here it is. Windows, put in here. Let me check. Yeah, we need to find a pop-up return. And it wasn't in the script that I was using before. Yes, here. Give me a second to find that script so I can show you guys the script. It's always stick to it. Let me check. Nah, come on. Well, as you can see that. Yeah, detecting bad characters. Yes, here it is. Ah, yeah, we have one problem probably. I think we have one problem that I was not. I did not. Nope. So we need to download Gnarly, and yeah, I did it once, and it is very nasty. Because you need to place Gnarly in the folder where Windows Debugger is. By the way, for those who are not well known with Gnarly, Gnarly is an extension in Windows Debugger that can help you with finding ROP gadgets, for example, and it can also display the protections that are in place in each module. As you can see, if we go back to Windows Debugger and I am entering the lm command from list module, then you see all the modules, as you can see here. You can also specify the m parameter and enter a module, and it shows you the start and end address of this module. It's very nice. But with Gnarly you can do even more than that. And that's what I'm going to show you. But we need to download it, extract GnarlyDL and copy it to the WinX folder for Windows Debugger. Okay, so let me download it. Oh my god, how many Gnarlys do we have? Let me do this one. No idea if this is the correct one. And we have our file, so let me open it. And we need we need this one, Gnarly. Let me copy paste both of them. Program files, XS, nope, it's not XS, program files. Windows, oh my god, okay, let me do it faster, smarter. Let me just open here a file location, open file location, there it is. And then we should have WinX. It says WinX, right? It did tell me to save it in WinX. To install and copy it to the WinX folder for Windows Debugger. WinX, yeah, okay. It should be placed here. And explicit error is keeping you from copying the file. If you could receive this error, what? Why is it? Why can I not copy paste it to here? Probably we need to unpack it. Extract. Oh yeah. Okay, give me Gnarly. It's really annoying this. Okay, Gnarly 64, and we need this one. Open. Oh wait. File location. Open file location. WinX. Yes, continue. Yes, continue. Okay, so Gnarly has been placed. Let me just check if Gnarly is indeed loaded by closing it down and attaching it again. See if Gnarly is indeed loaded. Attach. Audio converter. Load.gnarly. Nope. As I said, it's really Windows Debugger is sometimes really annoying with this kind of stuff. Oh no. What do we have here? We have Gnarly, finally. Well, forget what I said. So we have Gnarly, so we can do nmod, the command nmod, to display all protections in place. Now, as you can see, save structure exception handler is on, which is a bad. This is bad for us. This is definitely no go. Save structure exception handler is a protection that is preventing state of structure exception handler buffer overflow. What we are trying to do, it's preventing that. So this is a no go. If you check, for example, audio converter is off. But this one is also off, but as you can see, it has address space layout randomization and data execution prevention, but that's for a different time. But we need to choose one that has save SA off. So we can go for this one, or we can go for this one. I think we go for this one. It seems this one is the perfect candidate, as it has also no other protection in place. So let me do that. Let me do lmcd-rib. What the? Is this 64 byte? I think it's 64 byte. Let me try. Which are DLLs from? Okay, let me try this one. WMA-DMOE. Okay, weird. Seems they are all 64 byte. That's weird. I need to check for a DL that is of course coming from our target. But yeah, I don't see. You can probably check which DL are there by just open file location, and you can see the DLs here. For example, MMM-PDF. Let me check MMM-PDF. I saw that one. MMM-PDF. MMM-PDF. You guys definitely need to help me with finding it because I can't see. I'm blind. Anyone see it? I don't see it. Let me do a different one. Let me do check. MTF. Let me do that one. Yeah, we need to have a DL that is inside the program folder. Cannot. Is it even loading anything? Here you can see more, but it's really weird that you don't see more than this, but okay. So what we are looking for is a pop return. So let me check. Do I have okay, I can show you guys here. So for example, when we hit our EIP, so let me check. Let me continue and let me try batch pump. Okay, you can clearly see that our instruction pointer has 42, 42, 42, 42, right? So there are no more instructions. It's weird, but there are no more instructions, but okay. What we are trying to do is you have normally yeah, I'm going to explain. You normally have a stack like this. My painting skills are coming in handy now. Let me check. You have shapes. Okay, this is the stack, as you can see. This is the instruction pointer where we are at this point. You can see our 42, 42, 42. So here are our 42, 42. Yes? Okay. Then what we are going to do is it will hit our 42, 42, 42, but that will be the pop return. So what we are going to do is instruction pointer will go to our pop return. So let me check. Pop return. So this is our first pop. So what we're going to do here we have our instructions. So what we're going to do, we pop this value inside this register to here, to the value, to the to the pointer. Then we do it again because pop return. So we do it again. And this is our return. So this will jump back to the top or somewhere in the middle of our exploit. It will then continue down. So in summary, what we are doing is we are creating a loop. We are just going forward, backward, then jump, going down, pop return, going back, going down, pop return, going back, going down. So we are in a loop. And the idea is that we are going back and will enter our pop return again. But the second time when we are hitting our pop return, before we hit it, we will make a short jump. So we're skipping this part and we will make a short jump to here. Here we will have a lot of knobs, no operations, and then we will hit our shellcode. That's the idea of a structured exception handler. And as I will, hopefully I can, okay. And the structured exception handler is looking like this. I already showed it to you guys in the first session, but it's looked like this. Structured exception handler. Let me see if I can find it clearly. Yes, here, perfect. Oh my god. Okay, you can see here, this is how an structured exception handler look. It will first try to solve the problem by going to an address, first structured exception handler. But you have two pointers. You have a pointer to the next instruction handler. So this is the pointer to the handler who is going to try to solve the issue. If it will not, or if it cannot solve the issue, then it will jump to this address here. And then it goes to the next structured exception handler. Then the same thing will happen again. It will try to solve it. If it cannot solve it, okay, let's go to the next one, and then you will eventually come to the end of the list, and this is 0xFFFFF. And that means that there are no more structured exception handlers to go to, so it will just crash the program, it will just stop working and says, yeah, access violation, sorry, we cannot do anything. That's how the structured exception handler works. And what we are going to do is we're going to override these two registers. But the first time when we are hitting our structured exception handler, we are coming to this part where our pop return will be. So we will pop return, go back to here, and then we will go back up where we were at the same place. But then we will not hit our pop return again, but we will hit this one, the pointer to the handler, that register or that address. And there we will place our short jump. So we will skip the pop-up return for the second time, and we will jump, and we will pass by this pop-up return. So we will skip it, and then we will have a knob slide, no operations, and then eventually our shellcode. That's the idea of a structured exception handler. And where I was, oh yeah, we are going to find a pop return. So we have our gnarly extension. So if I do load gnarly, then we have, or I already have gnarly, yes. And we are finding a pop-up return, but the problem is, yeah, we can go for this one. Let me try this one, Noah and audio convert. Okay, we have the begin and the end. Let me go back to my Kali machine. Let me start MSV NASM shell. Okay, we are in our NASM shell. And what we can do with this, we can check for the opcode. We all know, or I hope you know, and if not, then you know it now. Instructions work with opcodes. For example, I want to do a pop AX. We can see the opcode for pop AX is 58 or 85. Sorry. Then we want to do another pop ABX, or we can do all registers if you like. Oh, So you can clearly see that we can choose of those pops, and we need to have a return, pop-up return. Yes. So what we are looking for is one of those options. So let me write a script to do this. Let me write you a script. Let me show you our windows. No idea if we can finish this pop return today, but I'm trying. Okay. And let me write this script for you. So what we are doing is 58 for the opcode we are looking for. F, the maximum that you're looking for. Okay. Okay, those are a for loop, but I think this is pretty clear to see. Without knowing programming, I think you can know that this is a for loop. So this is the comment we are doing inside Windows Debugger. With start and end, what I mean with start and end is the start address and the end address, what we just found, this. So copy paste this value, place it at the start, and copy paste the end, and place it at the end. Make it a little bit nicer. Save this file as, I don't know, whatever you like to be. Let me save it. And let me save it as find pop return with VDS. Okay. Okay. So now what we need to do, we need to execute it inside Windows Debugger. So that's what we're going to do next. So how to execute the script inside Windows Debugger is with this, a $sign and an arrow. Then the location of the file. So let me pick up the location of the file. No idea where it is. It is here, right? Yes. God damn it. I don't like this. Oh shit. I'm always messing with users or gebruikers. Gebruikers is Dutch for users. I'm always messing up with users or gebruikers. I don't know. What is this? Users. Okay. Viserion, desktop, and then the find ppr.bds. And we have a syntax error in our script. Why do we have a syntax error? Block for R $sign T0 0x58 T0 is kleiner dan 0x5f R should be correct. Why do we have an error? Syntax error in punt comma for R minus 0x85